calculator available to you today?
1 second, let me go get one.
Okay, definitely need that for compound interest.
I'm back.
Okay, very good. So compound interest, I'm gonna go with maybe that you're looking at this formula here, which is, we'll just keep it really simple. The future amount is the principal 1 plus the interest rate to the number of years t. Does that look somewhat familiar to you?
I've seen that, yeah.
Okay, any other context you can give me for your problem so I can, better help you?
Yeah, my problem was like, there's a couple of them, but they were like, you have like one was like you have like $100 it was like a odd amount,
Okay,
and you have compounding interest annually
yep,
for like 7% for 3 years. And I was able
okay,
to manually do that one with just like dividing and stuff. But then we had another one, which I know I'm not supposed to do that, but I was able to get the answer. Then we had one where it was the same type of question, like you have like 5% interest on like a certain amount, but it was for every month for 3 years, and I couldn't do that one manually,
got
so
it,
I didn't
got
know.
it, yeah. Okay, yeah, and so this formula I give you, I've written down here is applicable to, um it's applicable to annual interest, and then there's a modification, or I'm sorry, annual compounding, and then there's a more specific one for any other interval. So let's do that. Let's say you start with $200, and you're going to get, like you just said, 7%, and we'll just do it for 2 years. Okay, for 2 years. So we can do this a couple of ways. One is to look at it year by year. So in year one, okay, the amount of money that you'll have after year one is 200 times 1 plus 0.07. Why did I convert 7% to 0.07?
Because that's 7% of one.
You have to convert percentages to decimals. So to go from percents to decimals, you divide by 100.
Yeah.
Okay, and we're going to do it to 1. All right, so here we go. You have a calculator handy?
Yeah.
Can you calculate this for me, please?
Mm-hmm. 214.
214. That's how much you'll have at the end of the year one. Now, at the end of year two, you do the same thing, but this time you start with 214, 1 plus 0.07 to the power of 1. Could you do that calculation?
Yeah. 228.98.
Okay, very good. Now, what the power of this formula is that you don't have to do it this way, which is what you described to me. Because we actually don't really care how much money you have at the end of year one. We only care at the end of year two. So the power of the formula is that you can actually do it all in one step. You can say, okay, 200, 1 plus 0.07 to the power of 2. Will you calculate that for us, please?
Yeah. 228.98.
Very good. Notice these are the same.
Oh, yeah.
Okay. And that's the point. The point is that you don't have to do it year by year. In fact, it would get really slow if we had to do that to calculate, say, out for like more than just a couple of years, right?
Yeah,
No one,
that's the
no one would.
reason I had trouble because it started saying for months and I couldn't do it just by calculating.
Well, months is a little bit different. You actually can do the same calculation. It's just even more tedious. So let's do some problems here where you uh, we continue to work with this formula, but let's try to do it in such a way where we're calculating it from beginning to end. All right, so here is an example problem for you to look at. In this problem, I want you to identify what P is, what R is, and what P is.
E is 1.17.
Okay,
R is 9%.
okay,
Um, and T is 5.
good. Now we can't work with 9%. What should we convert that to?
0.09.
0.09. So your formula here is A equals P1 plus R to the T. Could you calculate that for us, please? And round to 2 decimal places because money is in 2 decimal places.
Okay.
Let me know when you have a value, please.
1.0. I went 1.80.
Yeah, $1.80. Okay. Okay. So the equation here, I'm gonna just kind of center it here to give you a little discussion here. The equation here has a bunch of unknowns. It has A, P, R, and P. I have to give you 3 of the 4 to be able to solve it. Okay. And for now, you will never be asked to solve for time. At least in this course, you will in a later course. The interest rate is also tough for you to solve for because you don't have enough information to be able to do that typically. But it is reasonable to say, well, could you calculate how much you start with if I tell you the final amount? Okay, so let's say you had a savings goal. You wanted to save $5,000 for a car, for example. Okay, and you know that if you invest your money well, you can get a rate of return of 12% per year. Okay, and you're how old again, roughly?
14.
14. So let's say we have 2 years to do that. Not a ton of time, but some time. Okay. We can use this formula to solve a real problem. Okay. So notice here that your future goal is to get to 5,000. We don't know how much you need, but we know that you're going to get a 12% return on your money and you have 2 years to do it in. Do you see that P is the only unknown?
Yeah.
So to solve for P, you first have to calculate this thing on the right and then divide both sides by whatever that is. Now you can actually do it all in one step, meaning you can divide by 1 plus 0.12 to the power of 2. But if you're not comfortable with that or don't want to do that, you can get that number over here. You know what I mean by that?
Yeah.
Okay. Could you attempt to solve this for P for us then?
Um. P.
Is it clear what I'm asking you to do, or do you need me to clarify?
No, I got it. Three, 9, 8, 5, and then 0.96 or 97, I guess, approximately.
So the good news here is that you don't have to save the entire amount. If you had this much right now in your pocket and you could get 12% interest, you would have $5,000 down the road. Have you heard of Albert Einstein before?
Yeah.
He famously called compound interest the eighth wonder of the world because of its importance.
That's nice.
Yeah, it's kind of an amazing thing. It's there's not many things free in life, and compound interest is one of them. Okay, so to answer the kind of the questions that you're really struggling with, that like everything we just did is a foundation for that. It's like most things in math, you never get the full picture until someone gives you the full picture. So this formula is actually that I gave you before is actually a simplification, a reduction of this formula. So notice it's got some differences in here. It's got n. N is the number of compounding periods per year.
All right, wait 1 second, 1 second. I gotta write this down. Um, okay.
Let me know when I can proceed.
I'm good. I wrote that down here.
Okay. Now, more importantly is than the definition is the actual like values of n that you might have. Okay. And we actually start out with the word annual. Annual means that n equals 1. Semi-annual means that n equals 2. Quarterly is n equals 4. Monthly is n equals 12. You see this on occasion bi-monthly. That's n equals 24. That one's pretty rare, but might as well throw it in the list. Weekly, n equals 52. And then occasionally you see the daily one, which is n equals 365. Do you remember which one you got on the test?
Yeah, it was monthly for 3 years.
Okay. So we're going to do a problem monthly for 3 years.
So does that mean it's 36?
Uh, what is what 36?
The N?
No, it means that n is 12. P is the number of years. Okay. So we're going to look at, some of the other things do not change in this formula. N is the number of compounding periods. P is still the principal. That's what you start with. R is the rate as a decimal. P is the number of years. Let me know when you're caught up here. We'll do a problem here.
I'm caught up.
Okay. All right. So let's say you want to invest $3,000 for 3 years, and the interest is 8% compounded monthly. Okay. We want to know what it's worth 3 years from now. So the formula is P equals A 1 plus R divided by N to the N times T power. What is the value of A in this problem? I'm sorry, I mixed these up. Boy, that's really bad.
3,000.
Yes, that's what you're starting with. Wow, that's wonderful. I can't grab that. So you're starting with 3,000. What is your interest rate as a decimal?
0.08.
And then divided by 12. And then 12 times 3. So that's where the 36 comes in. You were asking about that earlier. It is 36, but really it's the fact that N times T is 36.
Okay.
You're a good math student. So there's going to be some situations down the road where you want to be careful that you don't just jump to that. You want to work it out each time. Okay. Now, if you're using a scientific calculator, make sure this part is in parentheses.
Okay.
So could you calculate this for us, please?
Yeah.
And round to 2 decimal places because it's money.
Okay. How do you do fractions on the calculator?
What kind of calculator are you using for answer?
It's like scientific. It says Sharp Advanced DAL.
Okay. I'm going to just write it the way that I think you might be entering it. You put a slash for division and then some sort of an exponent 12 times 3. So to answer your question, the slash is the fraction part.
Okay.
Let me know when you've got a result here, please.
About 3,001 and 30 cents.
Like this.
Yeah. Well, like, yeah, with rounding.
Okay. Does anything bother you about this result?
Yeah, it's really small.
Yeah, that's definitely not the right result. You did the other ones correctly. So here's an option. I don't have any way to replicate your kind of calculator. You could first calculate the 0.08 divided by 12.
Okay.
Okay. Then you could add it to the 1, get that result. then raise it to the power of 36, then multiply by 3000. So without seeing your calculator, I'm not sure how to best replicate that, but I can also give you the Desmos Scientific. Drop that in the chat here.
Yeah, I got it now.
Okay, what is your final answer?
Um, uh, 3,810.71 cents.
That's much more reasonable. I mean, it had to go up by a significant amount. I mean, that's kind of the like, okay, did it actually, like, why? I mean, because why would you invest your money in something if it's not going to go up?
Yeah,
You'd rather just keep it. So these problems should, famous last word, should reveal that, doing that's good for you. Okay, let's look at another problem here. Like you to try this one on your own. Before I do you have any questions about kind of the setups? You have to identify, you have to identify these values, right? P, R, N, N, P, and then you have to put them into the equation. So good to practice one on your own here. Why don't you give this one a try? And if you have some questions, please ask.
okay. I got 1,624.28 cents.
29 rounded up, but close enough. I wouldn't make a big deal out of that. That's really good. Let me see if I can give you a more difficult one. So do you remember if the problems just ask you for the future amount or did they ask for anything else?
Yeah, all the problems were like you have a certain amount of money, well, except for one, but they're all like you have a certain amount of money. It goes up by this much every year uh, or this much every quarter, whatever. It goes up by this much for this many years, every like compounding, whatever period. But then one of them was that the value decreased by a certain percent every year
Okay.
for us, you know.
All right. Got it. So
But
here,
the only one, the one that I had trouble with the monthly stuff was just a regular one.
okay. Well, let me give you one more problem and then we'll do one where it goes down in value.
Okay.
Okay. So here is a problem for you to look at and solve.
Isn't appreciate go up though?
Yes, yes. And that's why I wanted you to see some words like that. But yes, this one goes up.
Oh, okay. I got an error message.
Okay. Tell me what, there's always the 5 values. There's, in this case, we're trying to find A. What is P? What is R? What is N? What is T?
Um, he is 110,000.
Okay, I
Uh,
agree.
R is 0.06.
Okay,
N is 1.
okay. I think I know where your error is. P is the number of years. It is not the year. The number of years. How many years are you investing this?
7.
Okay, so give that another try, please.
Okay. Got
Let me know when you get your result.
got 165,399.3285.
Right? But it's money, right? We're talking about money. You got to round to 2 decimal places.
Yeah.
Okay, I would say you've got this down. So let's talk about the other possibility, which is depreciation, something that goes down. Can you think of anything that goes down in value?
Cars.
Cars, it's a good one. Now, in truth, cars don't depreciate the way we kind of expect. They actually have a huge depreciation in the beginning, and then they kind of level out depending on the car like this. But for the purposes of this problem, we will do this type of depreciation. So what's your favorite, what's your kind of your dream car right now? Something you might
Um,
want to drive down the road someday.
I kind of want to get a Miata.
Miata. All right.
Yeah.
What's a any idea price on a Miata that you're looking at?
Not really. The only one that I could find for sale was like a really, really good deal, and it's not like a regular price. So I don't really know what the regular price
Well,
is.
I'm trying to get, yeah, I'm trying to get a rough estimate of what a Miata costs because I have no idea. I see a
Uh,
wide range depending on the years that you might. I mean, are you
yeah.
are you talking about a new one, a used one? Just, and we're talking about a dream car, just something you might want someday.
Well, I don't really know. I don't really have a dream car, but yeah.
Okay. Well, I just looked, and let's just say you're doing okay out there. You've gone to college, you got a good job, you saved up some money, and you're thinking, all right, I want to buy a $30,000 Mazda Miata. You saved up all the money for that, and you're like, all right, well, but I know as soon as I buy it, it's going to depreciate. Okay, and let's just say it depreciates by 5.6% per year. Okay, and you're curious, you're like, well, I wonder what it's worth in 3 years. Okay. So the key difference in this formula is that instead of in parentheses it being 1 plus, it's now 1 minus.
Okay.
That's the key difference. Now, I've also added a little wrinkle where I've made the percent kind of a unfriendly number. What is the value of R in this problem as a decimal?
0.056.
0.056. So it's 1 minus 0.056. You started out with a $30,000 vehicle and you want to know what it's worth at the end of 3 years.
Um, 25,236 and 97 cents.
Very good. So in 3 years, it's gone down a little bit. You got to drive it for 3 years. Maybe that's a good trade. All right. What's another situation? A lot of things depreciate. So let me just give you another scenario. So let's say you got something that starts out at $1,200. It depreciates at 1.2% per year, but it's compounded quarterly. So n equals 4. And we want to know the value after, and so here's like, again, we don't need to do that. Value after, we'll just say 5 years. Okay. So give this one a try on your own. I will also do the calculation. We'll see what we come up with.
I got $1,130
Okay.
and 1 cent. Oh, 2 cents.
Okay, good. All right. So I would say you understand it now. You probably, if you had this lesson yesterday, you would have gotten them all right. So that the fact that you can go in tomorrow and do a retake on those or finish up them, that's great. Any other questions from your test that you remember that you want us to kind of look at, think about, talk about?
I think I did pretty good on the other ones. There was like an area problem, like on the last test. And there was there's like a quadratic formula thing, so I just plugged it in and I found the value of x. So
Okay. You get a chance to redo any of those parts?
um I could I have like a short amount of time because what happened was the teacher accidentally gave us the midterm instead of the final. Um
Okay.
so she had to take it back from us because it was like for semester one
Okay.
and print out the new one. So we had like 15 minutes where we did nothing. And so she said if we come in like 15 minutes early tomorrow, we can have that extra time back to finish up problems.
Okay.
So I don't have that much time to redo the whole test, but
Let's do one or two. Let's do a quick quadratic formula problem. Does that sound okay?
yeah.
Do you know if it worked out nicely or not? Do you remember? Meaning like, was it
Um, I think it was like kind of like a long decimal thing. Yeah. So
you know
no.
if it had a square root in it? That's what I'm asking. It sounds like it did if it had a.
Yeah, it was one of those things where you put in the calculator and it just keeps on spewing out numbers.
Okay, very good. Let's try our problem here. Let's say it's x squared plus x minus 1 equals 0. Can you tell me the values of a, b, and c?
A is 1,
Okay.
B is 1, C is -1.
All right. Now, were you given the quadratic formula or did you have to remember it?
Uh, well, we were allowed to bring a piece of paper in, and I wrote down the quadratic formula on it.
That's a really good idea. All right. So here it is. I'd like you to just calculate the part under the square root. Just the part under the square root, please.
5.
It is 5. Good. So the next part here is to substitute everything else. -1 plus or minus the square root of 5 over 2 times 1. And this is probably what you meant by the calculator doesn't return a nice number. And this is the answer. It's just that it doesn't work to something that we're used to. Um, a few things you might do is you might show each solution separately, like -1 plus the square root of 5 over 2, -1 minus the square root of 5 over 2.
That's what I did.
That's great. That's fantastic. Okay, you feel pretty good about that. You mentioned an area problem. Was it an area of a rectangle with a patio around it or something like that?
No, it was a patio that you had to find the width of, and it gave you like the polynomial thing where or the quadratic thing where it's like x squared plus 14x plus 15 or something, you know?
Okay.
Or I don't know the numbers, but it was like
Sure.
one of those.
Right.
And you had to and it said one side was x plus 11, I remember. And oh yeah, it was x plus 11 and x plus 3. And were
Okay.
the sides I came up with, and together they were x squared plus plus 14x plus 33.
Okay.
But I don't know if I did it right because I just like put it in the box method, and I saw, oh, if there's 3 here it'd work, and that's how I did it.
Okay. Well, without knowing more details, it's hard to sort of make a guess on that. But it sounds like you're starting to remember. Like the more you think about something, you can sort of remember stuff. Anything else before we jump into maybe just some other stuff to talk about?
Not really.
Okay. So I'd like to spend the last 10 minutes of our lesson today working on SAT prep. And don't get too excited or too frustrated. It's actually could be interesting, but it's just some stuff to see where you're at with taking standardized tests. Have you heard of the SAT? Do you know about the SAT? What do you,
Yeah, I
if
think my
so,
sister has to do that.
okay. And you have not taken it yet, though, is what I'm hearing.
No, but I've taken like AZ merit and stuff.
It's a little different than that. These are national tests. These lead to scholarships and other things down the road here. Um, could you try solving something like this for me? And you're welcome to use the answer. Like here's the difference between this and the classroom. There's no work required. And I will never ask you for work on these because they're not about your ability to show work. They're about your ability to get the correct answer.
Okay. Wait, a negative plus a negative equals a positive, right?
It does, yes. But what I'm to be careful here. If you're trying the number, if this is what you meant, two negatives added together make a negative.
Oh,
I'm not sure if that's what you're referring to, so just be
no,
careful
yeah,
with
that's what I
that.
meant.
Okay. The order matters where the negative is.
So that's -7, not 7.
It is -7, yes.
Okay. Okay. Um, okay, so it's A.
Okay. And how sure are you of your answer?
I'm pretty sure.
Okay. All right. So, well, it sounds like you just tried the answers. Is that right?
Yeah.
And that's fine. That works. But what if the answer was D? What would that mean? You've tried A, you've tried B, you've tried C. Is that a good strategy, do you think?
I mean, I guess it's better to be safe than sorry.
So if you had unlimited time, if you had all the time in the world, which you don't have on these things, sure, you could always do that, right? But that's not reality. Reality is you have a time crunch. And so you have to decide whether you want to direct solve, which is kind of using your skills from the classroom, or, for example, try the answers. So here's another one to look at here. And you are welcome to try the answers. You're welcome to try and solve it.
D.
Okay, so 2 times 1 plus 1 equals 1.
No. I try to do it like algebraically.
Okay.
Um,
So I mean this one can be solved. They all can be solved. Your first maybe choice would be to either did you subtract 2z or subtract z?
I should drop 2z.
Okay, that's fine. So this becomes 1 equals negative z. Remember, it
Yeah.
has to be z by itself.
So then, yeah, I got that wrong. I just made it z. So then that's not right because
So what would z actually equal?
-1.
Yes. And unlike your test tomorrow, like there's no retake coming back in, it's all or nothing in these.
Yeah.
So you might sit here and say, all right, well, I mean, this doesn't look that bad. I'll just try the answers, right? And then I put a problem like this in front of you. What's the problem with trying the answers on this one?
Um, they're fractions.
They're fractions, which really, you're good at maths, and I think you probably would be okay doing this, but that's probably not the best route. Multiplying by fractions, making common denominators, things like that. I mean, that can get really cumbersome. You don't want to do that if you can. So this one you should direct solve, meaning work it out as if you don't have the answers.
Okay. How do you do that?
Just like you did in the previous problem. You have to get the
Oh,
variables on one side, the numbers on the other. This is something you did a little bit earlier in the course, but it should be something that's still familiar to you.
um, B.
Okay, you say B. How confident are you in your answer?
I'm really confident.
All right, let's
Right.
take a look here. Did you move, what did you move first?
2P.
Tell me which two pieces. You subtracted that from both sides. So you did the right thing here. You always move the smaller to the larger. All right, and I'm going to subtract 8 from both sides. So it's -2 equals 5p. Divide by 5, p equals -2/5. All right, good job. Now keep in mind what we're doing right now is just one content area on the test. The test covers essentially algebra 1, geometry, and some of algebra 2. And you know a lot of it. Some of the stuff I won't give you problems you haven't seen before, but I'm giving you stuff right now that you have because hopefully that helps you to work through some of these problems. The next problem I'm going to throw up in front of you here, you have a choice to make. If you try answers, there's two nice answers and there's two non-nice answers. You have to decide which one, what makes sense, or maybe direct solving. Maybe just go and solve it and see which one's right. I'll leave that up to you, but could you work this out and let me know what you come up with?
D.
I'm sorry?
Is it D?
2 times 8 minus 4, does that equal 8?
Yeah.
Yes, it does. So they are sometimes that simple. Okay. And there's no reason that you can't get a good score on something like this because, well, you've seen some of the stuff. Here is the problem that you should be able to work on. All right. It says, what are the solutions to the given equations? You can see that every single one of these is the quadratic formula.
Yeah.
So in your problem here, you have A, B, and C. What's the value of A from this equation here?
Three,
3. How about B
-7,
and C?
-1.
Good. Now I just want you to calculate the B squared minus 4AC. We're almost done. Give me just another 2 minutes of effort here. Be all
Okay,
done.
so this, C,
Don't give me your final answer. Just the B
oh,
squared minus 4AC. Yeah.
37.
Okay. And any concerns about doing it right or wrong with signs?
No,
Because
cause
because the answer is either 37 or 61, because there's those are the only ones there, right? And
yeah,
it's really easy to make a mistake. Okay. Meaning like it's either to go one way or the other. So how confident are you? Because they're both possibilities, right?
yeah, but it's 37.
You must be very tired. It is 61 here. The -4 and the -1 turn into +12. Or if you like 4 times 3 times -1, that's -12. They need negated to make +12, but it is 61. So that means it's either B or D. But all right. Good job on that though. I'm not sure if you've seen that stuff before, but really good